everybody, I'm Miss Cooksey, and today we are going to be talking about multiplying a polynomial by a monomial and then reversing it, so factoring out a monomial from a polynomial. Excuse me while I plug in my mouse. Okay. No, does not want to work today. There we go. Okay, so we're going to start with multiplying a polynomial by a monomial. We learned in the previous lesson that a monomial is a single term and a polynomial is more than one term. So we're going to multiply a polynomial by a monomial. To do this, we are going to use the distributive property. So we're going to multiply the coefficients and add the exponents. So I'm going to distribute, in this example, negative 2x to the third times negative 4x plus 8x to the fourth. I'm going to distribute what's on the outside. I'm going to multiply the coefficients and add the exponents. So negative 2 times negative 4 is positive 8. X to the third times x is x to the fourth. Negative 2 times 8 is negative 16. X to the third times x to the fourth is x to the seventh. Every time we multiply a monomial by a polynomial, that's all we're going to do is distribute. So here we would have 2x times 3xy squared, which is 6x squared y squared. 2x times 4y is 8xy. Remember, we can only add the exponents when the variables have the same base. And so here we would only combine the x's together. 6x times 3x squared minus 4 would be 18x to the third minus 24x. 2x times negative 7x squared minus 4x. Well, 2x times negative 7 is negative 14. X times x squared is x to the third. 2x times negative 4x is negative 8x squared. The same strategy works when we have more than one variable on the outside. Here we're distributing x to the third y. We're going to add all of our x's together, and then we're going to add all of our y's together. So negative 3, x to the seventh, 4 plus 3 is 7, y squared, 1 plus 1 is 2, minus 5, x to the fifth, 3 plus 2, y. Last but not least, we have 6pq times 3p squared plus 4q. We are just distributing our values. So 6pq times 3p squared is 18p to the third q plus 4q times 6pq, so 24pq squared. Once we feel confident in multiplying, we are going to reverse the process. So we are going to factor. Factoring means to reverse this. So we're going to go from the product, and we are going to find what multiplies to reach the product. These are called the factors. So we're going to find the factors. So to do this, we are going to find the greatest common factor of the two values, and we are going to make that what will be on the outside of parentheses. So the greatest common factor of 64 and negative 40ab is 8, because 8 divides into 64 and negative 40. Now we're going to look and see, so the greatest common factor goes on the outside. Then we're going to see what is going to multiply by the greatest common factor to get the original expression. So 8 times 8 is 64. 8 times negative 5ab is going to be negative 40ab. This is how we factor. We're finding what multiplies to get to this original value. So 4d squared plus 16, the greatest common factor between 4d squared and 16 is 4. Now we need to think, okay, if I was going to distribute, 4 times what is 4d squared? 4 times d squared is 4d squared. 4 times what is 16? 4 times 4 is 16. Now let's try one with a few more variables. 15ad plus 30a squared d squared. Well, the greatest common factor between 15 and 30 is 15. But these two terms also have some variables in common. They each have one a, and they each have at least one d. So 15ad is our greatest common factor. Now we need to think, what would I multiply by 15ad to get 15ad? Well, that would be 1. And then 15ad times what gives me 30a squared d squared? Well, 15ad times 2ad gives me 30a squared d squared. Next, we have 32a squared plus 24b squared. We're going to find the greatest common factor. Here, there's no variables in common, so we know that the greatest common factor is just going to be a number. So the greatest common factor between 24 and 32 is 8. 8 times 4a squared gives me 32a squared. And 8 times 3b squared gives me 24b squared. Okay, we're going to look at 3 more examples. Here, between 30 and 35, my greatest common factor is 5. Now I'm going to look at my variables. Each of these terms has at least 2 x's and 1 y. So 5x squared y is my greatest common factor. Now, what would I multiply times 5x squared y to get 30x to the third y? Well, 5 times 6 is 30, and I need one more x, so 6x. Now I'm thinking, what do I multiply times 5x squared y to get 35x squared y? Well, 5 times 7 is 35, and I need one more y. 75b squared g to the third plus 60b g to the third. Well, the greatest common factor between the two whole numbers is 15. That's the largest number that divides into 60 and 75. Now I'll look to see what variables they have in common. They each have one b, and they each have 3 g's. So 15b times g to the third times 5b gives me 75b squared g to the third, and 15b times g to the third times 4 gives me 60b g to the third. Okay, in my final example, I have 24x plus 36x to the third. The greatest common factor, the largest thing that divides into 24 and 36, is 12. Each term has one x in common. So 12x is my greatest common factor. Now 12x times 2 gives me 24x. And 12x times 3x squared gives me 36x to the third. So in this video, we did 2 main things. We multiplied a monomial by a polynomial by using the distributive property. Then we reversed that process and factored. So we took a product and found what multiplies to reach that product by factoring out the greatest common factor. Thanks for watching. I hope this video was helpful. Make sure you subscribe so you never miss a video, and I'll see you next time.